Hello everyone. So welcome to yet another video in this particular playlist on creating customized exams. So we had divided the playlist on creating customized exam into three sections. So that is section 1, that is 1.1, 1.2, so on up to 1.7, then 2.1 up to 2.9. So these are videos with different themes. In this first part of the tutorial, our focus was generating a demo question paper, which is common to everyone. Whereas in the second part, we shifted to the LaTeX environment and started programming and started adding questions. The programming part is done. We just now have to configure the supply the question file and it will start generating papers. Now I want to start section 3. That means officially this video will be video number 3.1. Okay, so why I am doing that is that now I want to start discussing about how to answer these questions. What is the way to answer these questions? Okay, so for this purpose, let me go to the one of the sample exams we created earlier. So we have so far created three questions. So let's look at the third question under the AC uh, by far, because this I think is the simpler one to start working on. See, I have the resistance value, reactance, that is inductance is there, and capacitance is there, and the question is about finding the current in polar form. Okay, now how do I find the current? First, I need to find the impedance. Then I need to find the reactance here and reactance here and so on. So let us try to do that. So for that, see, we have to add the solution also into the question file itself, so that I have both question and solution captured in the same place. So that tomorrow, if I want to do another software for automatically correcting the papers, I need to have answers also handy. So let's try to do that. So first, let me go to the procedure. Okay. So what is the procedure? How to solve this question? See, this 12 ohms will remain same. Now inductance is 0.18 Henry. That I have to convert into reactance. Okay. So that I will do. I can use any programming environment, but for simplicity's sake, as of now, I will use the this Excel file itself. So remember, we created the parameters RLC like this. Okay. Now, under the solution also there could be parameters. So I'm just introducing some three or four columns into this. Okay. Now let's call this as XL, inductive reactance. Okay, so X underscore L or whatever XL. So what is the formula for XL? That is 2 pi F into inductance L. So it is equal to 2 multiplied by pi. So in XL, the pi value will be pi within pi followed by bracket. So it will be taking as pi value. Now 2 pi f is 50. Now for this particular question, the frequency was fixed as 50. So 2 pi f into L. The L value keeps changing. So that is this element C6, the cell. Okay, so now this will calculate the capacitive reactance. Now I can say simply tick here. So the entire column is filled with these values. Similarly, in order to continue this, solve this problem, the capacitance is there. So I can calculate the capacitive reactance. So X underscore C. That is just a label. So instead of this, I'll say small x small l and then small x small c. Now, what is capacitive reactance? That is 1 divided by 2 into pi into f into C. Okay, so that, but whereas the C is in microfarads. Okay, so I have to say into 1e minus 6. Okay, so that microfarads I have to micro I have to give as a unit here. Okay, so in using this formula, I am calculating the capacitive reactance and I am saying okay for it. Now, you all know that inductive reactance will be of positive nature and reactive capacitance will be of negative nature in the imaginary domain. So, right now I am not keeping that imaginary, all that things, just because I know what this, anyway, I am calculating it. So, what is the net reactance? Net reactance, let's call it as XN, net reactance. XN. So what is the net reactance? That will be equal to inductance minus capacitance. So why inductance minus capacitance? Because inductance is positive, capacitance is negative, it will anyway subtract. Now in some cases the capacitance may be more, then the reactance will become negative. So for example, in this case we have only zero point 0.1 Henry of inductance and 60 microfarad of capacitance, whereas these three values are coming, these two values are coming as reactances. So net reactance is negative. That means the circuit will be capacitive in nature. Okay. Now, what is the impedance? Okay, so impedance, let's call it as Z. So what is the impedance? Impedance is nothing but resistance and reactance. Both. I have to simply do that. So if you know the formula, square root of R square, that is B6 square plus this square. Okay, so like this impedance formula I can calculate. Okay, so and then again I can say yes. So this will be the effective impedance. Let me just verify it whether I am correct. Okay, so this is the impedance. Okay, so by the way, I'll just number of decimals I will adjust. Let's go with 3 decimal places. Okay, so it is just processing. All right. Now I have Z value also. So now it is easy to calculate the current value I. Okay, so what is the value of current? So let's introduce two more these things. Current value I. So because in the question, what was asked, in the question it's saying, find the value of current I in polar form. So I need to find I. So I will be V by Z. Okay, so V is 100 and divided by Z is 14. So V is 100 already, it is specified. Okay, so now I am getting the current value. And if you notice, all these currents will be positive only because Z is also positive. Because even if there is any negative sign under this XN, because we are squaring and making square root, I'm getting like this. Now the question comes, how do I find the phase angle? Because here it is asked in polar form. So in polar form, I have to find the phase angle of the current also. Take V as the reference at 0 degrees. Therefore, depending on the values of XL and XC, the current may be leading or current may be lagging. But how do you find the phase angle? Okay, so if you go to impedance triangle, I'm just doing a simple Google search and then I'm going for images, and there is a impedance triangle in the Google search. So resistance is on the x-axis, reactance is on the y-axis, and the phi is the phase angle. Okay. So how do I get the phi angle? It is nothing but tan inverse x by r, because tan theta is opposite by adjacent. Okay, if I remember correctly my trigonometry. So so there are several all over the internet. You will have find a lot of this thing. I'm trying to find any formula. So anyway, here you can see one more XL minus XC. That will be the net reactance, and then it will be like this. Okay, so how to find tan inverse? So here you can see theta is angle of the Z, which is nothing but tan inverse of X by R. So this is our formula that is called impedance triangle. Now, how do I do tan inverse in Google spreadsheet? So tan inverse in Google Sheets. So it will tell me, probably A tan will be the formula. Yeah, that is it. So A tan is the formula. So I can simply say A tan and then the value. Okay, so it will give. So let's do that. So here I will say phase. So is equal to A tan. So I will do X divided by R. Okay. So again, like this. Now whatever value we got, this will be in radians because we are doing tan inverse. So radians, how do I convert into degrees? Into 180 divided by pi. Will be converting radians into degrees. So that formula I'll copy for the rest of the values. And the plus minus sign is also automatically taken care of, so I don't have to do any other thing. So the angle is also calculated now. So I have everything now, and let me again control the decimal places. So for the phase angle, I think one decimal place is enough. All right. For the current also, maybe let's keep three decimals for the current and all other values. So now I have the current and value. So everything is in polar form. Okay. So now I have all the parameters with me. So freshly, I will once again copy this. So I go to the end. So, in other words, what we have to do when we are framing the question, at the same time we are framing the question, we have to frame the answer also. And we have to calculate the parameters in the answer and we have to mention that. So, let's go to question bank and let's open our ACI.json file. So, in this ACI.json file, earlier I had only RLC. Okay, so and the values. So now I delete all this. So let me delete all this. So we had 300 randomly generated set of parameters. So and from this randomly one of the parameter values will be chosen. So now I am copying the new values. Okay, so these are our answers. Okay, so now I can simply replace. So first let me replace this. Control C, Control H, and this one I will replace with like this. Next, I will replace this Control C, Control H, and replace all. And then all the tabs I will replace Control C, Control H. Okay, now we have more parameters here, right? What are the parameters that I have? Again, I go to my spreadsheet. So these are the names I have given for parameters. Along with RLC, I got these additional parameters which I have to enter here. Now, why am I entering these values here? Because I will be utilizing this in creating the solution for the question. So make sure that you don't make any what do you call syntax errors here. So now I have the parameters and values. Save this file, and you can close this file. So, but anyway, I'll keep it open because now I will edit the text file. Okay, so what I do, I just go to this ACI text file. I'll open with Notepad instead of using that LaTeX. Now, after this, I just say begin. So this is a command in LaTeX to introduce the solution. Okay. So now what is the solution? So I'll begin the solution. The in reactance of inductor equal to dollar x underscore L equal to 2 pi f L. Okay, so I'm just writing the formula. So this is all in LaTeX format, which is equal to 2 into again pi into 50 into. Now here L, we already have this L here, right? So parametric. So dash dash L dash dash. So this will be the 2 pi f L. Now this will be replaced with our new parameter, that is we have just now created the parameter xl. Okay. So here I will say dash dash xl dash dash, and if I want I can also keep j here. Okay. So j xl, and then I can keep omega, and then finally close it with the dollar sign. Okay. So let's say this is itself is my answer. I am not solving completely. Only one step I have written in the solution. Okay. So this solution I want to appear in the exam. Okay. So what I should do? One small change I need to do at the in the beginning of the starting text. Okay. So when I go before begin document, I have to say print answers. Okay, so print answers. If I add this additional command, then wherever I have given this solution environment, it will print the solution. Okay, so let us see how it works now. Okay, so what I should do? Simply, I have saved this file save, and I have saved the JSON file also. And now I will go to number of exams, make it only one exam, and then I will, or maybe even two exams, and I will execute this. So before executing, let's delete the old files. If we keep clearing our folder, it will be not confusing. Okay, so now let's run. Is there a problem? Okay, the exam text file is created. In order to check whether where the problem has come. Okay, so doesn't matter. Let's run once again. So here there is a problem. Okay, so JSON error is there. So obviously we have done some error in the JSON file. Okay, so let's check that. So parameters RLC, XL, XC, XN, Z, and I. So 1, 2, 3, 4, 5, 6, 7, 8, 9 values. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9 values. This is also correct. See, the program got stuck because somewhere in the syntax of JSON we made an error. Yes. So this last comma I forgot to remove. Okay. So now you remove this comma because this is the last element in the list. There's no need to give a comma. Okay. So now let's clear the text files. Okay. Now let's run again. Good. So looks like it's running. So second time also it is running. So two exam papers might have created. So let's see. So here is the thing. Now automatically under the question there is a solution box which got created, and inside the solution box the solution started actually. The reactance of the inductor equal to XL, which is J43.982 ohms. Okay. Now let's add more steps to our solution. So simply go to this and then add one more step. The reactance of capacitor. xc 2 pi f. So basically, this is all 1 pi. So 1 divided by 2 pi fc. So that will be 1 divided by 2 into pi into f into c. So that will be entirely minus j and here xc. Okay, so remember all our xc's were positive. Okay. So now I got this. So save it. So let's verify. So it is better to be safe, add one question at a time and then you can keep verifying the answers. Okay, so let's see. Okay, so here one more line added to our solution. The value of xc is being calculated. So xc is 2 pi fc. Anyway, here I have to give a line break. I'll do that. Okay, so let me complete the r plus j into x underscore l minus x underscore c, which equal to dash dash r dash 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 xl minus dash dash xc, which equal to r plus xn so sometimes this xn will be negative, so j into xn. So impedance I got in this one. So the magnitude of so the current, your current I equal to V divided by absolute value of Z. Okay, so this is what is the formula, V by Z. In fact, I can just simply give V by Z, that is equal to 100 divided by R square plus, so here I will say SQRT let me do some brackets like this, and which is equal to, so we have one more parameter for Z, right? That is, yeah, just a small Z and then I. 100 divided by Z, that equal to I amperes. Phase of current I equal to, how to do tan inverse in LaTeX. So let me again search for that. Tan inverse in LaTeX. Backslash tan inv. Okay, I think it's just a power of minus 1 I have to give. So backslash tan to the power of minus 1, and then here fraction x xn by r, which is equal to phase. Already we are calculating in degrees. So degrees. So this is our final answer. Okay. So current in polar form. Dash dash I think there is something called angle. Let's see. Dash dash phase. So this is a complete solution. So let's see whether this solution comes properly in our editor. Okay. So I again run the file. Okay, LaTeX is executing. One more exam. Again, the LaTeX is executing. So here, if you see, I think the final question is coming xl minus xc. Okay, so and then z value is there. Okay, so I think for I have to use capital I. So tan inverse is also coming properly. I think this one should be minus at the top. That also I will take care. Okay, I think just let's run once again. So little bit of debugging will be there all the time. So here it will be capital I, and here it will be capital I. And what was the one more? Okay, so tan inverse. I think I have to give this minus 1 in flower brackets like this. Okay, so now again execute. So if you notice, we stopped editing the code. The code is now fixed and code is frozen. Only we have to apply and provide the files, and then it will create the exams. Let's look at the solution. Okay, so now we are getting more or less correctly. Okay, in the denominator, due to some reason, this r is not coming properly. So let's see what was the problem. Okay, here dash dash r and dash dash. So let's run once again. Final time. So again, I generated two exams. So probably this might be one of the newer files. Yes, now the resistance also coming. So here I can see the question here, 10 ohms, 0.24 and 90. So here with 0.24 it is 75 ohms and 90 microfarad it is this. Okay, here 10 to the power of minus 1, minus 6 I have to give because it's micro. And then finally the degrees also getting calculated. So the okay, so the here the phase of current and the magnitude of current 2.424 amperes at 76.0 degrees. So one more now different values. Okay, so I think I just stop it here into 1 e to the power of minus 6. Okay, so that micro I am adding. I simply say 10 to the power of minus 6. Just one exam I'll create finally. I know the video is becoming very long, but just bear with me. I just want to finish one set of how to create solutions to your exams. So on the coding side, nothing has changed. Just we need to add a solution environment to the question. If it is there, then the solution will be included. Otherwise, solution will not be included. Which one is the latest file? Not this one. So let's arrange. So this is what happens if there are multiple files. So let's do one thing. I'll delete all the files and then just run once again so that there won't be any confusion to identify the latest file. Just one exam I'm creating. Here it is. So here 10 to the power of minus 6 also has appeared. So now everything is correct. So this is the solution. Now where do I have the solution? I have solution in two places. One place I have solution in this PDF itself. Under the question I have the solution. So in the other place, if I go to question bank, I have all the solutions in the this JSON object. Okay, so if I go to this JSON object, for any question, I have the solution ready here. So either I can pick the solution from here or from the LaTeX object or from the PDF, and later I can do that. So if I don't want the solution to be displayed, then simply I go here and then I'll comment out this. So just give a percentage sign. If you give a percentage sign, then LaTeX will consider it as a comment. And then now if I execute, so whatever new file gets created, so that file will not have the solution. Okay, so because we have commented out, so here the solution doesn't appear. So I can anytime switch on the solutions or switch off the solutions by doing this. And you might imagine now the same process repeats for creating a solution to DC circuits. Anyway, this video has become very long. I'll stop it here. In my next video, I'm going to propose a request to all my students and all my subscribers to submit your questions. Okay, so that is the purpose I made all these playlists. The next one will be the last video in this particular playlist of creating customized exams. So thank you so much if you have come up to here. Just one more video I'll make. Have a look at it and then please attempt and please submit questions. Okay, so that it will help me and help you. Thank you so much.